Let's talk about selective photothermolysis, the core principle behind how all laser and light-based treatments work. I know it sounds fancy, but it breaks down beautifully, and this is how I like to explain it. Every wavelength, whether we're talking 420, 1064, 2940, is selective to one or more of the 5 chromophores: melanin, hemoglobin, water, bacteria, and tattoo ink. The second part of the term, photo, means light, thermo means heat, and lysis means a controlled micro-injury. The selective part is key. We're not trying to burn down the whole neighborhood. We're trying to knock down the front door, hand deliver the right amount of heat, and walk away without causing damage to the rest of the tissue. Science first. What are we targeting? In aesthetics, our targets are called chromophores, which just means color-loving molecules that absorb energy. We have 5 main chromophores: melanin, which is pigment in hair, skin, and sun damage; hemoglobin in blood vessels; water in all tissue, especially the dermis; bacteria we treat in breakouts; tattoo ink, multiple colors, each with its own wavelength match. So here's the deal. Each chromophore absorbs different wavelengths of light. Melanin loves shorter wavelengths like 515 or 560. Hemoglobin, prefers a little bit deeper, 560, 590. Water and collagen-rich tissue absorb longer ones like 1470 and 2940. So you choose your wavelength based on what you're targeting. That's the selective part. The photothermolysis part is what happens next. So, real-world analogy. Imagine using a magnifying glass to focus sunlight on a piece of paper. You're not heating the entire yard. You're concentrating energy on one specific spot until it smokes. That is selective photothermolysis. Laser energy passes through the skin harmlessly until it finds the chromophore it's built to target. Then boom, it gets absorbed, turns to heat, and creates a controlled micro-injury, just enough to destroy the problem and trigger healing. So no guesswork, just clinical precision. No diffusion, no overheating, just targeted transformation. Moving on to TRT, thermal relaxation time, one of the most misunderstood but most important concepts in laser safety and efficacy. The science, in real words, TRT refers to the amount of time it takes for a target like melanin or hemoglobin to cool down by 50% after being heated by a laser. What affects TRT? Well, first of all, the size of the target. Bigger targets equal longer TRT. Chromophore type. Melanin definitely has a different TRT than hemoglobin. Location in the skin. Deep targets may cool slower than superficial ones. So a few analogies that might help. Microwave versus oven. Think of a grape versus a roast chicken. A grape cools quickly after zapping. A roast holds on to heat longer. A capillary equals grape, so a short TRT. A big vessel or dermal structure equals roast, a long TRT. Take, for instance, this photo, frying an egg. You want just enough heat to cook the yolk, not burn the entire pan. Too much heat or too long equals burnt, aka collateral tissue.